Here's a really good overview of how hot air, see the hot air indicated in red from the engines, comes and gets pressure, temperature regulated, and then goes into the pack, okay, as 200-degree hot air, 30 psi, and comes out freezing cold. When it comes out, this blue line is 0 degrees plus or minus. It's so cold, in fact, that we can't put it in the cabin like that. So we remix hot air with it. This hot air. Okay, so this valve here and this valve here modulates, opens and closes, and gives more or less hot air depending on what the pilots have selected in the cabin. So it adds and takes away hot air to make it comfortable or to match the pre-selected temperature that the cabin crew have selected or the flight crew have selected. Okay, and once it's temperature regulated and pressure monitored, regulated, it then gets released into the cabin. It's two channels or two sides, and both sides you get some air from pack one, the majority of the air going into the cockpit, and some of it going into the cabin. And then pack two, the majority of the air going into the cabin and some of it going into the cockpit for interchangeability and for redundancy, etc., etc. Okay, so the air conditioning system keeps the passenger and the flight compartments to the required temperature, humidity, and cleanliness for the comfort of the passengers and crew, both on the ground and in flight. It also ventilates the components located in the avionics compartment. So we have avionics cooling system here. It also provides ventilation for the lavatory. So it's air bled from the engine or from the ground cart. Okay, so we have a ground cart that could provide air. Okay, and then what happens is the air enters the cabin and is pressurizes also the cabin, temperature regulates, and we can't have the air going in and blowing up the cabin and blowing it up and blowing it up. Obviously, it discharges, okay, at a certain stage. But the discharge of it is such that there is always a positive amount of air, of pressurization in there to keep the balance right for passenger comfort. So just like we had the bleed, all green is all good. Now we have the air conditioning, all green is all good. So we have the air from the packs. It's green, it means it's good. But in the other picture we saw it's red because it's hot. Excuse me. And if it's still good, coming out of the pack, okay, it will then get distributed to the cockpit and the cabin, where the passengers can then select from the PSUs these gas booth things where they can select the air for passenger comfort. Okay, we said in this condition here, both bleed valves are closed, HP bleed valves are closed, and the supplied air comes from the LP compressor at high engine RPMs. The cross feed valve is closed. Okay, and each pack is supplied by its dedicated engine with air at around 25 psi. Here we can see now indications on the pressurization page. We have a bit of differential pressure. It's quite a bit, actually. It's around about 4.5 psi or 387 psi differential pressure. Okay, that's quite quite a good amount. It's a 3.87 atmospheres. So the inside, the difference between the inside of the cabin and outside of the cabin is 3.87 atmospheres. One atmosphere, if you can imagine, it's all the pressure from outer space to the ground. All of that pressure. 1 atmosphere, so it's the difference here is, and that equates to, on a normal day, equates to 76 centimeters of mercury. Okay, this is showing us that it's at the moment it's 3.87 times more between the inside of the cabin and where the aircraft is at its given altitude outside. And the rate of climb is 0 feet per minute. In other words, the cabin rate is not changing. I'll put this in just to show us what began as the Airbus dark cockpit philosophy, which ATR, which is a daughter company of Airbus, adopted. All right. So the dark cockpit philosophy pertains to, has a philosophy of everything that's on the aircraft that's selected and is good is not on, it's dark. In other words, there's no indication. Okay, because it's nothing there for the pilot to see if A, it's switched on, and B, it's working. Okay, this is the idea of dark cockpit philosophy. You start getting lights on when you have a fault. Okay, so a fault you have to know about, so it will come on in amber to get your attention. And the cue when it comes on, when the fault comes on in white, in amber, is to press that fault light and switch that system off. So the fault indication gets replaced with the off indication. You can't have both on at the same time. It can't be faulty if it's off. Okay, and if it's on, it's black, so the off light is not indicated, and the fault light can be illuminated. Okay, so that's the principle. All the push buttons, all right, that have a on-off function, the square ones, they will be black. If they're on and working, they will be indicated white off if they're switched off, deliberately switched off. If they're not deliberately switched off, but they're off, then we'll have a fault light because the condition of the switch, which is pushed to be on, and the system are not in agreement. So then therefore we'd have a fault light. Okay, the other ones, the other non-square ones are only indications, and they're only amber. They're black, means they're working, or they're amber, or giving us a message. All right, and here we've got both the aircraft system display with the actual panel. And if you moved this panel and moved it over here, you'd see exactly what everything operates. Okay, so at the moment on the aircraft, we have the pack valve is faulty. There's a fault light there. The bleed is faulty. We have a bleed fault there. Okay, the bleed valve is closed. And we also have an overheat and a bleed leak. So in an overheat situation, if the overheat is too much, the bleed valve will automatically shut down. Okay, and this is probably what's happened. So now the switch, the switch was switched on, but the valve automatically closed because of an overheat. And because it overheated and closed, the condition of the push button and the valve position do not agree. Therefore, we get a fault light. And it probably shut down automatically because there was an overheat or a bleed leak. All right. If this is shut down, therefore there's no air going into the pack, And if there's no air going into the pack, then the pack will be faulty as well because it's not receiving any air, so it's got no air to condition to put into the cabin. All right. This is the cue then to the pilots, to operate this cross bleed valve here to use the hot air from the other working engine, to supply this pack here. And if you cross bleed, if you perform the cross bleed here and open this valve, it can open automatically through computers. If not, you can manually open it, and once you do, then this valve indication will go out because then the pack is getting hot air supply. Okay, here is it's a bit small, but it just gives us the idea of how the air comes really hot into the pack, and then it gets heat exchanged. Okay, through a compressor, it gets compressed and gets really, really, really hot first, and then it gets condensed. And once it gets condensed, it gets super cooled. It gets compressed again and super cooled, and it ends up going in a space of a few pipes. It goes from 200 degrees hot to 0 degree temperature. So much so to the fact that we have to add hot air to it to make it comfortable before we put it inside the cabin. Okay, that's for a working pack with a working engine. We also have here a inlet, a turbo fan that pulls in air when the aircraft is on the ground and the engines aren't rotating. Okay, to give us conditioned air inside the cabin when the aircraft is not moving. Okay, or when the indicated airspeed is less than a given amount, or the aircraft is on the ground on a nice hot day and the cabin's boiling, you'll have this turbo fan here. This inlet will suck in air, okay, or take in ambient air and put it through the ringer to be able to produce some cold air to put inside the cabin, or when the engine's not running. And here's the whole panel, the whole air conditioning panel. Okay, so it's more or less in 3 sections. This is the bleed section, supply from the engines. This is the air conditioning section. The conditioned air into the cabin. And this here is own pressurization. And this here is the Avionics vent. Okay, so we use the air also to cool the avionics, we said, and that's what that panel is up there. So a lot of buttons again, but they all have the same principle. We know the principle of the fault lights and the off lights. Now we have a temporary condition. Okay, if we manually override it. So if there is a manual possibility, then you see on the side of this push button, it's saying this one functions automatically. But if you press the push button into the manual mode, you then become the monitor. It's not getting monitored automatically. You are now the monitor of it because you are taking control over it. Okay. This is for temperature selection. So usually the temperature is automatically monitored. What we mean is the pilots, they select a given temperature they want in the different zones. Okay, and the computers, the valves, all the systems, the packs work towards retaining that selected temperature. If for whatever reason the temperature is not attaining that position, then we can manually override the valve positions, and are able to monitor or control the temperature ourselves, okay, by rotating these, okay, counter rotating them. beyond the 6 o'clock position, and then open it, making them hot and cold. We have recirculation fans, which assist airflow. Don't forget, 90% of the air that is coming from the engines into the cabin is recirculated air. So we recirculate it for conditioning because it's precious. We don't want to hold, again, the magic word of compromise. We don't want a hole too big in the cabin to expel too much air, because A, we'll have problems pressurizing, and B, it will be a loss of air, and therefore it will be inefficient to our systems and our flight. So we try to keep the expulsion of the air to a minimum, expulsion from inside the cabin to out to a minimum, and we recycle the air that the air cycling machines, the packs, are producing. And we assist by using these, we assist the recirculation by these two recirculation fans. And the avionics vent, we'll see in a minute how the avionics vent works, but it is quite an intricate system on how the air is cold air is sucked in one way and blown over the avionics and then pushed out overboard out the other way. Okay, so it's a good intricate little system on how it does the avionics cooling. All right, we've seen this picture before. We've seen how the indications can come if everything's fine. And then we can see how, if we have a recirculation, if the recirculation fans are problematic, if one of them, then one of them will be amber. If both of them, then both of them will be amber. Okay. There's not much you can do about it in flight. If the recirculation fans are not working, then the air is there. It's just not to the standard that it was in terms of purity when the system was working. Okay, so nothing will happen. It's just that recirculated air is always better than non-recirculated air. Or, yeah, filtered air is always better than non-filtered air, especially if someone's got smelly socks on. Okay, and if we have a overheat, a temperature overheat of the pack, here we'll get, a temperature overheat of the duct, of the air conditioning duct. Then if the air in the cabin is then getting too hot because the duct is getting too hot, we'll also get a indication here for the crew to take the necessary action. So much so that we put all the warnings possible, okay, or all the indications with the warnings here, so that itemized, so that you can take in the image in case one comes up in the exam. Take the image or the picture and then put some words into where it is displayed on the aircraft and what it means. And here we have our famous avionics ventilation. Okay, so in normal configuration, we have a system where this is the avionics here, and the avionics has a load of screens. There's a load of racks here that produce a lot of heat. Okay, so what we do is we take some cold air and we pump it through. Okay, we pump it through the avionics, and then we extract the hot air, okay, and pass it underneath the cabin floor. Now remember, guys, if you remember, here on the aircraft is a cargo area. Okay, so by extracting this hot air, warm air, it's not hot, it's warm, we are putting it underneath the floor and making it here at a reasonable temperature. So if we were, for example, transporting live animals, it wouldn't be freezing cold. It would be at an adequate temperature here because of this warm air that's coming underneath the floor from this extract fan. Now, Imagine if we had a smoke in the air conditioning system or in the cabin or in one of the avionics caught fire or smoking, yeah, and we put all the smoke, extracted it, and put the smoke underneath the floor. That wouldn't be a good idea. Okay, so in a situation of a smoke, we um, shut this valve off, okay, and open this valve here. We partially open this one. So we open it in this in normal configuration is closed. It's flush with the airframe. Okay, it's this one here. It's flush with the airframe to be able to enable pressurization, comfortable pressurization. But if we close this one, then we have to open this one. But if we open it fully, then the aircraft will depressurize. So we open it enough, just enough. It's called the partially open position in the smoke configuration. So it's opened enough to expel the air because it produces a Venturi effect under pressure and it gets sucked out. But it's not opened too much to lose in terms of pressurization. Okay, so the warm air that has now smoke in it doesn't go inside the cabin anymore under the floor. It gets diverted and gets sucked overboard. All right, and we have means to manually override these valves. If the valve didn't open, for example, and we had to open it, we have means to manually override the system. That's called avionics ventilation. And the indications of it, okay, the usual things. It's green, it's working. Okay, if it's amber, it will come on amber and tell you what is wrong. So there's an exhaust fault or the overboard valve is faulty. And the blue, we said, is a temporarily selected item. Okay, so you select override. So in this case, you've overridden it. It comes up in blue because it's normal. See the norm here? It's no longer in a normal configuration. You've selected the override function of it. And last but not least, pressurization. Okay, so we pump air into the cabin. We don't let it escape too quickly in order to be able to pressurize it, the cabin, that is, to a level where when the aircraft takes off and the altitude of the aircraft increases and also the cabin pressure increases, yeah, that the shock of being from sea level to 6,000 feet isn't too much. So what we do is we pre-pressurize the aircraft. So this happens on every flight. When you get on, when they shut the doors, they pre-pressurize the aircraft to simulate an altitude of, let's say, 8,000 feet. It's around about 8,000 feet. So when you're inside the cabin before even takeoff, the cabin pressure is as if we're at an 8,000 foot high mountain. Okay, this is so that when we take off, the transition from sea level to the actual altitude is smoother. Okay, now we have all this is done by an outflow valve that opens or closes depending on how much air we want to let expelled to maintain the cabin vertical speed, the differential pressure inside the cabin. We can also pre-program it if we give it a departure elevation of an airport and the arrival elevation of the airport, and then it will make us a pre-plan, a pressurization schedule from takeoff, the cruise to the landing, and depressurize or unpressurize or unpressurize the aircraft before we open the doors after landing. Okay, so it's all automatic. However, there is a manual system to override it if it failed. This aircraft has a pressure and a cabin altitude ceiling of 25,000 feet. Remember when we did oxygen last time? We said not every passenger gets an oxygen mask. They saved on a few oxygen masks because at 25,000 feet, some people live at 25,000. All those people in the Himalayas, they live at 25,000 feet. They live and breathe. Or South America, they got some pretty high mountains. Some of these people live at such altitudes. I think it's is it Lima Airport? Maybe it's Lima Airport is at an altitude of 8,000 feet, which is is it 8,000 or 8,000 feet or 8,000 meters? I'm not sure. It's pretty high, pretty high. Okay, so 25,000 feet is not as much as your normal airliners, which go up to 35, 39, even 41,000 feet. So if you had a rapid decompression at 25,000 feet within 30 seconds, you'd be pretty comfortably coming down, descending to a breathable altitude where your oxygen masks will no longer be required. Okay. Here are all the indications again. You can play them back and watch them on your on the video if you replay it. And if there's any questions, here are all the indications of what all the buttons mean. We did say anything that's got normal or auto on the side of it means it has a manual selection, which are usually indicated in light blue because it's a temporary indication. Okay, and here you can select the landing elevation. You can select the departure elevation and then the landing elevation, and then feed it into the computer, and the computer will then manufacture a pressurization schedule from takeoff to landing. The crew can monitor it all through the flight, and they do. And usually you want a vertical speed of 0 feet per minute. In other words, the cabin altitude is neither climbing or descending. In other words, your ears will not be popping, because that's what makes them pop, because of the cabin altitude is changing rapidly. Okay. And this one is the differential pressure, which shows the difference between the inside of the cabin and the outside of the cabin at that specific altitude. And again, the indications here are all displayed, what everything means. Okay, red is not good. Red requires immediate attention by the pilots. Okay, so if we go past 6 point something, differential PSI means we have to take immediate action and depressurize the cabin somehow, because otherwise we don't want to overpressurize it, because rivets will start giving, I reckon. There are systems in place. There are overpressure valves that are on springs that will just push out, okay, if there is an overpressure. However, you should, in normal situations, never get this red indication here.